Hello. Welcome to this session on leveraging distributed tracing in Kubernetes and containerized environments. My name is Chinmay Gaikwad. I'm the technical evangelist at Epsagon. A bit about myself. I have had a variety of roles. I started off as a software engineer and then moved to a lot of different roles in big companies as well as smaller startups. A fun fact about myself, I love traveling. And this picture essentially is from a place called Sapa in Vietnam. If you haven't been to Vietnam, I'd highly recommend it. So let's get started with the session. In this session, we'll see how microservices have become the new normal. And then once you have something that has become a new normal, there are also a lot of challenges. So in this session, we'll focus specifically on the observability challenges and why do we need a new outlook. We'll also see how to implement a good observability solution using distributed tracing. So as most of you might have noticed and have gone through the journey, architectures have shifted from being monolithic to being microservices based. Applications are now broken down into something called as mini apps, which can be scaled easily and also can be managed easily. So if you want to update an application, you don't need to update the entire software stack. You can update just the microservice, and that has made it easier to manage application. We at Epsagon have also seen a lot of different companies benefiting from this microservices transformation. And this benefits are not restricted to a particular industry type. It's across industries as well as across company sizes. So like huge companies such as Adobe and Vonage have used microservices to go to market faster or develop features faster. Even smaller startups such as Choco and Fabric have used microservices for the same reason. But as Werner Vogels once said, everything fails all the time, and I completely agree with it. So how does this relate to the microservices world? It essentially boils down to the fact that microservices have made the architecture much more complex. So it's very difficult to troubleshoot and fix problems in a microservices based world. Let's go a little bit deeper on this. So what has become difficult and why has it become difficult? So if you're building a microservices based application, you essentially use cloud as your platform. So you interact with a lot of cloud APIs such as AWS APIs or GCP APIs or Azure APIs. On top of that, you also use a lot of third-party APIs such as Stripe or Auth0. So the culmination of all these APIs have made it really difficult to troubleshoot. On top of that, containers and serverless functions can scale really fast. So there is no defining behavior pattern here. And because the behavior pattern is difficult to predict, it also becomes difficult to troubleshoot. And finally, the logic of the code has shifted from within a service to calls between different microservices. That's a shift in the mindset that has come across, and that's why it has become really difficult to troubleshoot. This also has a lot of business impacts. As you can see, almost 3/4 of the issues are found by customers before the operations team can figure it out. Also, every minute of downtime costs companies around $8,000. Those are huge numbers. So how do we actually reduce these numbers? That's where observability comes into picture. So what exactly is observability? We can define observability as a culmination of 3 pillars: metrics, logs, and traces. Metrics essentially tell us what exactly is going on within an application or in the infrastructure. Logs tell us why something is happening, and traces tell us where exactly it is happening. So why do we need a new outlook because of this change? It's because traditional observability solutions are not designed to monitor microservices-based applications. So for example, as I mentioned before, the logic of the code has shifted from within a service to between microservices, and traditional APMs were used to monitor monoliths. They can't really handle the microservices between the calls observability. On top of that, the traditional APMs are manually instrumented and are heavyweight. So if you're using cloud resources, you would want your agent to be lightweight and auto-instrument it. Also, traditional APMs focused more on infrastructure monitoring, but the focus has shifted from infrastructure to application monitoring. And finally, even though traditional APMs have log aggregators, logs don't really work as a great starting point for debugging and troubleshooting microservices-based architecture. Why though? For explaining this, we'll go through a use case for the session. So for this session, we'll just consider a very simple example of a virtual shop. As you can see, the HTTP server authenticates requests using auth0 and pushes them to the Kafka stream. A Java application polls the stream and updates the Dynamodb table. And let's say there is a scenario where users complain about orders that were sent but not handled. So where would you start? Metrics are a great place to start. You might have seen a Kafka dashboard similar to this. Here, as you can see in the dashboard, all the metrics seem completely normal. There are no spikes anywhere. So you would want to see another microservices dashboard. Now we look at the Dynamodb metrics dashboard, and here you see some spikes. Now that's very interesting. And especially interesting because you see a count of user errors. So why do we see the spikes? We definitely need more data to understand why the spikes happen. And when we need more data, we need more logs. But as I mentioned before, logs really don't work as a starting point. That's mostly because each microservice produces at hundreds of lines of log lines. And if you have hundreds or thousands of such microservices, you'll have to go through 100,000 log lines. That's a huge effort. So in our virtual shop example, if you go through all the log lines produced by different microservices, you'll be lucky to find what exactly is happening. And if you're lucky, here, as you can see, the key is missing, it'll definitely take you a longer time. And as we have seen before, every minute of downtime costs you thousands of dollars. So if this is happening in your production environment, it's going to really affect your business. So let's take a pause here and see what exactly is missing. The things that are missing are correlation between metrics and logs and correlation between different services. So how can we correlate this? That's where distributed tracing comes into picture. For those of you who don't know, a trace essentially is a flow of requests through different microservices. Just because your application consists of hundreds or thousands of microservices, that doesn't mean every request will flow through each one of them. At most, it will travel through a fraction of those microservices. So we at Epsagon believe that an observability solution based out of distributed tracing should help you throughout your engineering lifecycle. We call this the engineering flywheel. So on the right-hand side, you can see that the observability solution should be able to help you with designing phase. That is by predicting the dependencies between different microservices during implementation phase, which is basically committing code with confidence. And on the left-hand side, you can see that an observability solution should help you with testing as well as production issues troubleshooting. So let's look at how we can actually use a good observability solution based out of distributed tracing for these purposes. So because a distributed tracing-based solution tracks all the transactions through different microservices, it's very easy for the observability solution to build something called as service maps, which can create an entire architecture overview for you. In this way, you can actually analyze whatever you had designed has been implemented in practice. You can also see which are the problematic microservices and the latencies between them. When you are developing new features, you can see how new microservices interact with the current microservices and if there are any problems. So you can essentially commit them with confidence. As I mentioned before, a distributed tracing-based solution tracks request flows. And with this, you can bring the focus to the problem. So you can essentially clear out the noise and focus on the microservices that are problematic. In this way, troubleshooting gets really fast. You can also see how much time is being spent in each microservice. In this way, you can easily track performance issues and latency issues within your application. One of the most important things that a tracing-based solution does is correlation between metrics, traces, and logs. Because of the correlation, you have a huge amount of data at hand. A good observability solution should allow you to slice and dice the data as you want. So a couple of examples are shown here. So you can see the count of errors as well as total items ordered. So you can track engineering as well as business level metrics and see why exactly are you seeing those metrics. The same holds true for errors and exceptions. You can slice and dice errors by error codes and exception by exception types and see why exactly are they happening. This will help you focus on important errors such as 500 errors and exceptions. On top of all this, as I mentioned before, the logic of the code has shifted from within a microservice to between the calls of microservices. So payload information has become really critical. So if you can see the payload information, you can actually see what's been transferred from one microservice to the other. And these days, if you face a lot of issues, you get a lot of alerts, but the alerts are without context. That kind of creates an alert fatigue. With a distributed tracing-based solution, you can actually create contextualized alerts. When you get to contextualized alerts, the troubleshooting point is further down the line, and you can definitely reduce your mean time to detection and resolution. So let's come back to the example that we saw before. As a reminder, the problem here was that users complain about orders that were sent but not handled. So using a distributed tracing-based solution, you can see the flow of the request through different microservices. As I had mentioned before, you can only focus on the microservices that are involved in the transaction, so you can cut down the noise. As you can see here, that if you focus on the Dynamodb microservice, the key ID is missing. Which key ID though? Once you focus on the Kafka microservice, you see that the username is missing. Now you want to find out why exactly is it missing. Then once you focus on the auth0, because of the payload information, you can also see that the JSON token has expired. So in case of auth0 specifically, you might want to use refresh tokens because the access token has expired. So in this way, the troubleshooting of this particular scenario was reduced by quite a lot as compared to the troubleshooting using just metrics and logs. So let's recap of what we saw in this session. We saw that microservices-based applications have their unique benefits and challenges. We saw the challenges with respect to observability. We also saw how observability using distributed tracing-based solution has its own unique advantages and is a perfect fit for microservices world. Observability built using distributed tracing-based solution helps you keep track of your entire architecture, detect performance issues, and reduce mean time to detection and resolution, as well as save a bunch of costs. I'd like to end this session just by saying that a great observability solution helps you shift your mindset from being reactive to being proactive. And that's it for this session. If you want to check out our exclusive giveaways, please visit the website mentioned here. It's epsagon.com/unscripted21. And thank you for attending.